Hello students, welcome to IMS Academy. In this particular session, I am going to discuss the previous year questions which are asked in the SSC JEE exam. This is the second session regarding network theory subject. In the last session, we have covered regarding network theory subject the questions which are asked in the SSC JEE exam related to the sources and then resistor and then inductor. Okay, with respect to those three concepts, whatever the variety of questions and important questions are there, so all those questions we have covered in the previous session, and whoever not yet watched that particular session, so kindly all of you watch that particular session in your free time, right? And whoever visiting our YouTube channel very first time, so all of you kindly subscribe our YouTube channel and click on the bell icon so that you will be getting instant notification whatever the upcoming videos which we are uploading in our YouTube channel. Okay, you won't miss even single video. Okay, and all of you like and share this video link with all of your friends so that they also will get benefited from this particular session, right? And before I am going to start today's session, I am going to give one important update. So this is our Telegram channel, IMS Academy Telegram channel. Regarding the link already provided in the description of this particular video, all of you kindly join. Okay, whoever not yet joined till now, all of you kindly join in your free time. So here in this particular Telegram channel, whatever the upcoming live sessions which we are doing, either live sessions or recording sessions, etc. So regarding that particular schedule you are getting, and whatever our faculties will write during the live session, that particular notes we are sharing in the PDF form in this particular Telegram group, and you will be getting all the important updates related to the seminar or webinar which we are going to conduct in future, and even you are getting all the job notifications related to the government jobs and PSU jobs. All those notification updates you are getting in this Telegram channel, and on daily basis you are getting the quiz question also in this particular Telegram channel, right? So all these benefits you are getting for free of cost. So all of you kindly join our Telegram channel. Okay, right. I hope all of you are eagerly waiting for this session. So let us start. Okay, so in this particular session, I am going to cover the previous year questions which are asked in the SSC JEE exam related to these concepts of network theory subject. So we are going to cover the questions based on capacitor, and then with respect to KCL, KVL, and then with respect to voltage division rule. Okay. Similarly, in the upcoming sessions, we are going to cover the previous year questions based on the continuation concepts. Okay, right. And whoever missed the previous session, so kindly watch that session in your free time. Okay, it is going to give maximum benefit, okay, for all of you. Okay, in this particular session, I am going to focus on these concepts with respect to the previous year questions which are asked in the SSC JEE exam. Okay, right. So this is the question based on capacitor. Okay, so here in this question, yeah, you can observe here. Here in this question, the capacitance of a parallel plate capacitor having two plates of area is given as 200 centimeters square. Okay, and separated by a distance d equal to 10 centimeter. Those two parallel plate capacitor is having the two parallel plates, right? So the two plates are separated by this much distance, 10 centimeter, okay, is given by. So that means we have to calculate the capacitance value we have to calculate. Okay, and here in this question they have given one more data, the permittivity of the medium, that is 8.854 into 10 power minus 12 farad per meter. Okay, by using this data we have to calculate the capacitance. Okay, I hope all of you know this formula. Capacitance equal to epsilon into A divided by D. Okay, here epsilon value given 8.854 into 10 power minus 12, right? And area here it is mentioned 200 centimeters square. 200 centimeters square. Okay, divided by distance 10 centimeter. Okay, here centimeter one time will get cancelled. Okay, right. And then here 10 will get cancelled. Okay, otherwise we can do in another way also. Just one second. So for the timing I'm not cancelling. Okay. Now here you can observe centimeter we can write it as 10 power minus 2 meter, right? There 10 power minus 2 is nothing but 1 by 100. So 100 and here 200. That means 2 zeros are getting cancelled, right? Now just multiply 2 with this number. Just multiply 2 with this number. So from here you are getting 2 4s are 8, 2 5s are 10, then 2 8s are 16 plus 1, that is 17. Then 2 8s are 16 plus 1, that is 17. Okay. After that, here 100 into 10 power minus 2, both are getting cancelled, but in the denominator you are having 10. So that 10 I am bringing into the numerator. So what will happen? 10 power minus 1 into 10 power minus 1. I hope all of you are getting a clarity, right? Fine. Now 10 power minus 12 into 10 power minus 1, that you can write it as 10 power minus 13. So this one we can make approximation, right? So we can write like this, 10 power minus 13. Okay. And this one, if you want to make approximation to 1 decimal place, then the value you are getting like 17.7. Now this 10 power minus 13, if you observe, here 17.7 into pico is there. Pico is nothing but 10 power minus 12. But here you are getting 10 power minus 13. Okay. But if you observe the choices, okay, you are having in the order of microfarad like this. Okay. So for the timing I am writing like this, 10 power minus 7 into 10 power minus 6. Okay, units are farad. Okay. So 10 power minus 6 is nothing but micro. So that means here it is satisfying. You can observe 17.7 into 10 power minus 7 microfarad. Yes, very good. So that is satisfying. Okay, 10 power minus 6 is nothing but micro. So from here you are getting 17.7 into 10 power minus 7 microfarad. Okay. So in this way, whenever you are calculating any parameter or quantity in the given question, have a look at the choices first. Okay. If you are having all the choices in the same order of units, then no problem. Okay, you can completely solve. But here, whenever you are having the choices like with different units, okay, that time you have to, like, after you are getting in between intermediate solution, okay, at that point of time just cross check the solution, okay, whether that particular value is matching to any of the choice or whether we have to do some adjustment. Okay. Say for example, if you are getting, suppose example 17.71 into 10 power minus 12, suppose. Okay, in that case 17.71 we can approximate to 17.7. In that case option B will satisfy. But since you are getting 10 power minus 13, right, and here when you have observed the choices, okay, you are having microfarad, okay, so then I have split it accordingly. Micro is nothing but 10 power minus 6. Okay, this 10 power minus 13 I have written as 10 power minus 7 into 10 power minus 6, right. So this 10 power minus 6 is nothing but micro. So then in this question it is satisfying with option D. Okay, right. Yeah, next question, it is based on energy with respect to capacitor, right. So in this question, yeah, you can observe a capacitor that stores energy of 8 joules and has a capacitance. In this question they have given the capacitance value 1 farad, has a potential difference. Okay, how much potential difference or how much voltage across the capacitor you are having, that is a question, right. So I hope all of you know the standard formula regarding energy stored by the capacitor. Just like energy stored by the inductor, similar formula you are going to have. Energy stored in the capacitor is equal to half CV square, right. So here in this question energy given 8 joules is equal to half into capacitance value is 1 farad, into V square. Okay, just do the cross multiplication. From here you are getting V square equal to 16. From here you are getting V equal to 4 volts. Right. So that means option B is the correct one. This is the direct question, direct formula based question. Okay, energy equal to half CV square. Right. Next question, all of you give a try. This is a question based on capacitor. You are having the circuit with the help of capacitors. Now you have to find out the equivalent capacitance across the terminals A and B. Across the terminals A and B, you have to calculate the equivalent capacitance. Equivalent capacitance. All of you give a try. Yeah, what is the answer you are getting? All of you can mention. See, for every question, okay, whatever the answer you are getting, you can mention the question number and your answer in the comment section. Okay, right. So here you can observe these two capacitors are connected in series, right? These two capacitors are connected in series. Whatever the formulas you have learned with respect to resistors, especially regarding the equivalent resistance, right? So whatever the formulas you are getting with respect to resistors, similar formulas will applicable for inductors, whereas for capacitors exactly opposite. Okay, here capacitors are connected in series. Okay, if the resistors are connected in series, then we have added, right? But here, since capacitors are connected in series, okay, so here you are getting the equivalent capacitance as C1 C2 by C1 plus C2. Okay, C1 C2 by C1 plus C2. So that means here 4 micro into 3 micro divided by 4 micro plus 3 micro, that means together I am writing 7 micro. Whatever the formula you got for resistors parallel connection, similar formula you are going to get for capacitors in series. Okay, so in this case micro will get cancelled. 4 3s are 12, 12 divided by 7 microfarad. 12 divided by 7 microfarad. Okay, now this entire configuration, okay, you got one single capacitor, right? Now that capacitor and this capacitor both are connected in parallel, both are connected in parallel. So in this case C equivalent, we are going to get like this. Okay, since capacitors are connected in parallel, now we can use the formula just like resistors connected in series. Similar fashion you are going to get. So that means here in this case C3 plus whatever the capacitor just now you got that value, that is 12 by 7 microfarad. Okay, so C3 value given as 1 micro plus 12 by 7 micro. So here you can do the LCM, that is 7. Here numerator you are getting in the order of micro, right? Now 7 into 1, that is 7 plus 12. 7 plus 12 is 19 divided by 7 microfarad. So the equivalent capacitance across the terminals A and B, you are getting 19 by 7 microfarad. Okay, see here in option A you are having 19 by 7, but here the units are micro, but here you are having directly in the order of farad. So that is the reason this is not the correct one. Option A is not correct, right? So in option D you are having 19 by 7 microfarad. Okay, so you have to take care about the units carefully, right? Okay, obviously other two choices won't be correct, so you can eliminate. Okay, I hope it is clear for everyone, but generally few students may do silly mistake. Okay, whatever the resistor series formula is there, similar formula they may apply here. Okay, you should not. Okay, exactly opposite you are going to get. Okay, right. So this is a simple question with respect to duality concept. All of you give a try. Duality concept. See here they are asking the dual pair of the with respect to node. For node Node means you are applying what? With the help of node, you are doing one analysis that is called nodal analysis. Similarly, the dual of that one is mesh analysis, right? So the dual of node is mesh, okay. And similarly for open circuit, the dual is short circuit, short circuit. So you are having option C, okay. So you are having like nodal analysis. You can solve the question, suppose one question you can solve with the help of nodal analysis, right? So for that circuit, if you apply dual, you are getting mesh analysis. Dual of nodal analysis is mesh analysis. Okay. Similarly, here you are having KVL, right? So actually KVL and KCL are dual. Okay, KVL, KCL are dual. Okay, and then any other parameter? No, all are covered. Okay, so I hope all of you got the clarity. For voltage, dual is current, right? Similarly, for the nodal equation, dual is mesh equation. Similarly, for KVL, dual is KCL, like that. Okay, so with this understanding, all of you give a try for the next one. It is very simple. Here also they are asking dual pair. But here in this question itself, they have given 4 terminology, like voltage source is there, current source is there, and then inductor is there, capacitor is there. Okay, just now I have mentioned for voltage dual is what? Current. That means for voltage source dual is current source. You can observe regarding current source, you are having 3 choices. Okay, the starting parameter is voltage source dual is current source. Okay, so that means as of now we can eliminate option B. Okay, next current dual is voltage, current dual is voltage. Yes, okay, all the 3 options like A, C and D are satisfying. A, C and D are satisfying. Now here you are having inductor. Inductor dual is capacitor. Okay, inductor dual is capacitor. Here also it is satisfying, but here it is resistor. So as of now we can eliminate option D. Option D we can eliminate. Okay, next. See, the moment dual of inductor is capacitor, obviously the dual of capacitor is inductor, vice versa, right? But here you are having resistor, so we can eliminate. Okay, option A we can eliminate. So only option C is left over, that will be correct. Yes, you can see here inductor. See, it is very simple. In general, you are having 2 basic electrical quantities, right? One is voltage, another one is current, right? So voltage and current are dual to each other. Okay, similarly inductor and capacitor dual to each other. Okay. Next one, in this circuit you are having voltage source is there, 2 inductors are there. Now they are asking the dual network. Okay, see, they have given one network. Okay, in this network they are applying the dual. Okay, in the dual network what you will be having? Okay, just now we have mentioned voltage source is there. For voltage source dual is current source. Okay, just observe current source you are having, yeah, 2 choices are there. That means other 2 choices we can eliminate, right? Here whatever the voltage source value is there, same value you are going to get. Value is not changing, only the dual source you are getting, that's all. Okay, since you are having voltage source, here you are getting current source, and in both the choices they have given same 15 only. Okay, since it is current source, units are ampere. Okay, next, here you are having inductors. Okay, regarding inductors, just now we have mentioned the dual of inductor is capacitor, right? So here you can observe in both options they have given capacitors only, because you are having 2 inductors, accordingly they have given 2 capacitors. But in option A, whatever the inductor values you are having, they have done the reciprocal, whereas in option D they have considered as it is. Okay, just now, just like voltage source, current source, we have just replaced the given source with the corresponding dual, but the value is we have considered as it is. Similarly here regarding the inductor, we are replacing with capacitor, the value you are going to get same. Okay, there is no change. Okay, so regarding the capacitor, here 3 farad, similarly here 12 farad, so that means option D is correct. So option A we can eliminate. Okay, I hope it is clear for everyone. Okay, sometimes few people may do silly mistake here because they have given 3 Henry. Now when they are applying dual, the value is going to reciprocal, like that some people may misunderstand, but here whatever the value you are having, same as it is, okay. So here option D is the correct one. Okay, so with this understanding, all of you give a try for this question. All of you give a try. See, in this question also they are asking the dual. Okay, so dual network of the figure shown below consists of. Okay, just like earlier question, you are having voltage source. Okay, voltage source dual is current source. Voltage source dual is current source. Okay, so as of now we can eliminate option A. Option A we can eliminate. Okay, in option B you are having the same value 10, in option D also same value 10, but in option C you are having 1 by 10. So that means we can eliminate even option C also. Okay, voltage source dual is current source because you are having 10 volt, here you are getting 10 ampere. Okay, right. Now you are having inductor, inductor dual is capacitor, right? Inductor dual is capacitor. Here if you observe, after you have eliminated A and C, only 2 choices are there, option B and option D. Okay, option B, option D you are having. In both the options, okay, you are having one inductor, one capacitor, one inductor, one capacitor. Okay, actually inductor is present here. For inductor dual is capacitor. For inductor dual is capacitor. Okay, here inductance value is 3 Henry. So the same value, that means 3 you are getting, 3 farad. But here how much they have given? Reciprocal they have given. Okay, so that is wrong. Okay, I hope all of you are getting clarity. See, here in the earlier questions they asked the dual pair. Okay, when they asked the dual pair, then accordingly, suppose for first source accordingly, okay, second source accordingly, third element accordingly, fourth element accordingly, in the same order you should have. Okay, but in the previous question, okay, you are having voltage source and then 2 inductors are there. They have asked with respect to dual network, what are the elements are present. Okay, so they have given exactly same order, but in this question they haven't mentioned exactly same order. Okay, but whatever the elements are there, okay, with respect to voltage source they have given current source accordingly in the same order, but after that you are having inductor and capacitor. Okay, so for inductor actually they have given capacitor here, and similarly for capacitor 2 farad they have given the inductor here. Okay, since it is 2, actually here also you are getting same value 2. Okay, so I hope all of you are getting the clarity. Whenever they are asking the dual pair, then exactly the same order, whichever option is satisfying, definitely we have to consider. But whenever you are having the network and if they are asking in that network what are the elements present, that time in some questions they can give the choices in the same order, in some questions they can give the choices in the different order also, but you have to take care about the values. Okay, so among like that you can observe among the given choices whichever is most appropriate, then accordingly you can choose, no issue, right? I hope all of you are getting the clarity. So here you are having 10 volt source, 3 Henry inductor and 2 farad capacitor is there. Now in the dual network, what are the elements present? In the dual network, 10 ampere current source is present, 3 farad capacitor is present and 2 Henry inductor is present. Okay, so the answer for this question is option B. Okay, sometimes it seems to be that like apparently you may feel that option B initially may not be correct, but with respect to like right away we have eliminated A and C, but after that anyway option D is not satisfying with respect to when you have correlated the with respect to values, right? So among that obviously option B is correct. Okay, so in this way what I want to tell is whenever they are asking the dual pair, okay, if they are asking the pair, then accordingly whatever the elements are there in the same order, accordingly the dual element should present. But whenever you are having the network, okay, in some questions they can give like this also, that time you should not like eliminate the choice, rather you focus. Suppose here you are having inductor, so that means here in this circuit one inductor, one capacitor is there. That means when you have applied dual, obviously one capacitor, one inductor should be there. Like that just observe the choices, and then whatever with respect to inductor, accordingly the same value you are going to get for capacitor, and whatever the capacitor value is there, exactly same value you are going to get for inductor. Like that, which choice you are having, in that way you can cross check, in that way you can easily attempt or you can easily choose the correct option. Okay, right. Yeah. So with this understanding, I hope all of you can answer this question easily. This is also based on dual, okay, duality concept. So in this circuit, you are having 10 volt source, okay, which is connected in series with 2 ohm resistance. Okay, only 2 elements are given. One is voltage source, another one is resistance. Obviously, voltage source dual is current source, right? Here you are having 10 volt, that means you should get 10 ampere, 10 ampere. So only one option is there. You can observe 5 ampere, 5 ampere. We can eliminate straight away. And here they have given voltage source. Straight away you can eliminate. Okay, the moment you have eliminated, option B is left over. Straight away you can choose. Okay, now you might be having the doubt. Okay, whether it is really correct or not. You can verify, no issue. Here you are having 2 ohm resistance, right? For resistance, dual is conductance. For resistance, dual is conductance. And just like for inductor, dual is capacitor, in the same way, for resistor, dual is conductance. But here also sometimes people may do, because conductance is what? Reciprocal of resistance. Okay, based on that, because they have given 2 ohm, here they will be considering 1 by 2 ohm. Okay, but here just like inductor and capacitor, how you got the same value? In the similar way, here you are going to get the value wise same. But conductance units are what? Mho, or reciprocal of resistance. Okay, so that means here you are getting units are mho, or you can say Simon regarding conductance. Okay, I hope it is clear for everyone. Anyway, in this question there is no confusion, but in any question if they have given choices like that, that time you should avoid that kind of silly mistake. Okay, just like inductor dual is capacitor, you are getting the magnitude wise same value, but only units are going to change, right? In the same way, regarding resistance, dual is conductance, value wise you are getting same, but units are going to change, that's all. Okay, yeah. So up to now we have discussed with respect to capacitor and then with respect to duality concept. Okay, now we are introducing regarding the basic laws. Okay, right. So all of you just read the sentence. Okay, from the given context, according to the given context, so which law we can apply, that is a question. Okay, so in the case of circuit laws, the currents flowing in various conductors in an electrical circuit are calculated by applying. Okay, so since they have mentioned with respect to currents flowing in the conductor, so obviously we can apply KCL, Kirchhoff's law. Okay, Kirchhoff's current law in more appropriately if you want. Okay, you are having KCL and KVL, right? So with the help of those laws, we can easily calculate regarding in any conductor if you want to calculate the current. Okay, right. Yeah. Now this is the question based on the KCL. You can observe here in this question they have mentioned that you are having a particular node. Okay, to that particular node, what is happening? Two currents I1 and I2 are entering. Okay, you are having one node. To that particular node, I1 and I2 are entering. Okay, so that means here we can consider for a particular node, okay, in whichever branches currents are entering, you can perform the algebraic sum of all those currents entering. Okay, that should be equal to in from that node in whichever branches currents are leaving, right? All those currents you have to perform algebraic sum, that's all. Okay, in this question they have mentioned that three currents like I3, I4, I5 are leaving from that particular node, right? So that means we can write I3 plus I4 plus I5. So it is very simple. Here KCL is nothing but sum of entering currents equal to sum of leaving currents. Okay, now the question is, if KCL is applied at that particular node, the correct equation will be, okay, whether we are having like this equation, just observe. No, see I1 plus I2, but here I1 minus I2, so that means option B we can eliminate first. And regarding here last equation, if you observe 3, 4, 5 we are having, but here 3, 5 and then I1, this one also we can eliminate. Okay, Now other two choices like option A and option C, you are having left hand side all the 5 currents you are having, right? So that means for the time being, if you bring these 3 terms to the left hand side, okay, it will become negative. So now you can observe I1 plus I2 you are having as it is, and these 3 currents are becoming negative, and since you brought all the terms to the left hand side, right hand side you are getting simply 0. So that means option C is correct. Obviously option A we can eliminate because all the currents you are having what? Plus. See, if all the currents are entering or if all the currents are leaving, then in that case option A will be correct. But in this question, some of the currents are entering and some of the currents are leaving. Okay, whenever you are getting like that, okay, you can rearrange like this. Okay, I hope all of you are getting the clarity. Okay. Yeah. Now this is the question based on KCL. Okay, in this way, some questions in the SSC JEE you will be getting directly theoretical based questions, and some questions you may be getting based on the simple calculation with respect to circuit, right? So in this question, you have to apply KCL and you have to calculate this current I. Okay, just now whatever we have discussed KCL, you can apply here. Just observe here, in this particular branch, okay, so in this particular circuit, you are having a node here, you are having a node here, right? To this particular node, if you observe, this current is entering, this current is also entering, and this current is also entering. 3 currents are entering. Okay, I hope all of you are getting clarity. So here 3 currents are entering, so I am considering entering current sum one side, 2 ampere, then 120 ampere, then 14 ampere current. So these 3 currents are entering. Sum of entering currents equal to sum of leaving currents. So here you can observe this current is leaving and this current is also leaving. Okay, these 2 currents are leaving. You can observe from this node current is leaving, from this node current is leaving, right? So that means sum of leaving currents I plus 24. Sum of entering currents equal to sum of leaving currents, right? Now here you can observe, like if you carefully observe, like 20 plus 4, that means 24, right? Here also 24 is there, 24 are getting cancelled. Okay, after that if you observe, here 2 I am considering as it is, here I have considered 20, right? That means here 100 is left, okay, and here I have considered 4, that means 10 is left. Okay, 10 plus 2 is 12, 12 plus 100, that is 112. Units are ampere. I equal to 112 ampere. So that means option B is correct. See, in this way, if you observe the equation, okay, from there you will be coming to know how easily we can do the calculation in simpler way. Okay, see, of course, some of you might have done that addition of all the numbers and then separated. No problem. If you are comfortable like that, you can do it. But the moment you have observed here 24 is there and luckily here 20 is present and 4 present here, in that way you can do the calculation in simpler way because 24 is already present. So that 24 you can eliminate from these numbers, and whatever the leftover number is there, you can do the addition in the mind level also. Okay, so in that way also we can easily cross check. See, first and foremost, if you observe option A, option B, magnitude wise you are having same, but polarity wise opposite you are having, right? But here if you observe, 3 currents are entering and 2 currents are leaving, but here the net current is what? When compared to here, here only 24 ampere is leaving, but here you are having more value, right? Obviously you are getting I value positive. Okay, in that way also you can justify whether whatever the sign you are mentioning or choosing the option, whether it is correct or not also you can justify also. Okay, that is also most important because when you are attempting any questions regarding SSC JEE with respect to the current or voltage, that time you have to take care about the sign also. Okay, yeah, so this is the question once again based on KCL. Okay, now if you carefully observe, here you are having one node B, you are having a node B. Okay, you can observe here to this particular node B, in this branch 11 ampere current is entering, 11 ampere current is entering, right? In this branch 7 ampere current is leaving, in this branch 7 ampere current is leaving. Now tell me, in this branch they have mentioned the current value as I, Okay, now can you tell I value how much? You have to apply KCL here, that's all. If you apply KCL at this node, you will be getting current value I. See, just closely observe. Here 11 ampere is coming, out of which 7 ampere is leaving. That means here in this case 4 ampere should leave. That's all. Yes or no? If you observe 11 ampere is coming, together 11 ampere is leaving. Yes, it is satisfying KCL. Okay. Now since current is coming like this, okay, obviously you are having plus symbol here and then minus with respect to voltage polarities. Okay. 4 into 10, that is nothing but 40 volts. 40 volts. So here you are having between the points B and A, between the nodes B and A, you are having B side you are having plus sign and A side you are having minus sign. That means it is a 40 volts. But in this question, what they have asked? In this question, they have asked the voltage value VAB. VAB means between A and B they are asking, right? So VBA is nothing but minus VAB. See, with respect to B and A, you are having positive. With respect to A and B, you are having negative, right? So that means VAB equal to minus 40 volts. Okay. So in this question, option D is the correct one. That's why I have told you have to take care about the sign with respect to voltage or current. Whenever you are having options like some options are positive, some options are negative, that time you have to take care about the sign also. Okay. You may be getting magnitude wise correct, but polarity wise if you are not taking enough care, then you may be choosing wrong answer. Okay. But if your basics are strong, definitely you can choose the correct option. Okay. Right. Next question, this is the, when you are looking at the question, you may feel that, sir, we may require more time for solving the question. But if you are good at visualization, especially for network theory subject, if you are good at visualization of the given circuit, you can easily solve most of the questions in less time. Okay, right. So in this question, what they are asking, the voltage across 11 ohm, resistor, they are asking. That means here, voltage across 11 ohm, they are asking. Right, fine. Voltage across 11 ohm resistor in the circuit shown below. You are having the circuit like this, right? Just observe here. Okay, I will give some time, all of you give a try. After that, I will discuss whatever I have given the hint point, how you have to visualize the circuit. Okay, that hint point I will elaborate, but meanwhile, all of you give a try. Yes. Yes. What answers you are getting? All of you can mention in the comment section, right? So just observe here in this question, if you carefully observe, here you are having one voltage source. Okay, I am representing here. Instead of drawing the circuit, whatever the voltage value you are having, that I am representing. 19 V1. You are having 19 V1. Okay, and here if you observe, horizontally we are having one resistor, but across that resistor you are having the voltage like this, voltage polarities minus plus. Now for the timing I am keeping this resistor vertical element like this. The moment if you are keeping vertical element, then you are getting the voltage polarities like this, plus minus V1, plus minus V1. I hope all of you are getting the clarity, right? Okay, you can observe here. Here minus is there, here plus sign. Yes, minus plus, and then here minus, and here top plus. Okay, so now you can observe, since you are having voltage polarity same, that means what we have to do? We have to add the voltages. If polarities are different, then we have to subtract. Okay, so in this case you are getting plus minus 19 plus 1, that is 20 times V1. 20 times V1. Okay, now if you carefully observe this entire part, okay, voltage value we got, that is 20 V1, right? Now if you carefully observe, okay, suppose this entire circuit I have replaced with one voltage source, example, that is 20 V1. Now that is one voltage source is there, here 4 ohm resistor is there, here 10 volt source is there. All these three, how they are connected? Parallel. In parallel, voltage should be same. Yes or no? But here you are having voltage polarity is minus here, plus here, right? So here I am representing minus plus 10 volts. Okay, so this voltage and that voltage should be same, because here 4 ohm resistor, this voltage source and this voltage, all the three are connected in parallel. That's why in parallel voltage should be same. Okay, so from here, because polarities are opposite, okay, if you are having same polarity, you can consider as it is, but since polarities are opposite, so now what we have to do, 20 V1 is equal to minus 10, or you can consider like this, plus 20 V1 is equal to minus 10, right? So from here 1 0 will get cancelled. From here you are getting V1 equal to minus 1 by 2 units are volt. Minus 1 by 2 is nothing but minus 0.5. Okay, in this question they have asked across the 11 ohm resistor how much voltage is there, and here it is mentioned V1, right? So when you have mentioned or when you have represented this resistor vertical element, you are getting voltage across that particular resistor as V1, right? So that V1 value they are asking. Actually in this question they could have more elaborated, instead of mentioning that voltage across 11 ohm resistor, they could have mentioned that you have to calculate V1 value. Okay, so as per the answer key, option D is the correct one. Okay, that's why actually in this question they should have mentioned instead of 11 ohm, because here you are having two choices, right? Just observe here, minus 1 by 2 is there, plus 1 by 2. But in order to support this sentence, okay, if you want to justify that whatever the resistor is there, that resistor you keep vertical element, then you are getting plus minus, then there is no confusion at all. But when you are looking like this, then some of you might have attempted this question by choosing option B. Okay, so that time what you can do, just like this arrangement you do, then you are getting polarities exactly same. Then whatever the final value you are getting, accordingly you can choose, that's all. Okay, I hope it is clear for everyone. Yeah, next question, all of you give a try. Yeah, in this question you are having one circuit like this, okay, and we are supposed to find out the current value I. Current value I. Okay, so here if you observe, all the elements are connected in the closed form, right? It is forming a loop. Okay, so we can apply KVL around this particular closed path. Okay, so here I am mentioning the polarities. Here minus, plus, plus minus, then plus minus. Now since current is flowing like this, right? So since current is flowing like this, voltage polarities you are getting like this, plus minus. Otherwise here you can do one more observation. If you observe 10 ohm and 30 ohm, these two are connected in series. In series we can add the resistance. Together you are getting 40 ohm, and the current I is flowing like this. That means you are having plus here and then minus here. Okay, if you have replaced this entire two resistors configuration as single resistor, then plus sign here, minus sign here. Okay, right. So now you can apply KVL around the closed path. Okay, I am applying KVL. Then when you are applying KVL in any closed path, for every element you can consider the second polarity, or for every element you can consider the starting polarity, no issue. Okay, for the timing I am considering the second polarity, minus to plus, plus 30, then plus 2 minus, minus 50, then plus 2 minus, minus 10, then once again plus 2 minus, minus 40, minus resistor is 40 into current is I is equal to 0. See, I have started from this particular point, I started from this particular voltage source, and I have ended at the same. Okay, you can observe 1, 2, 3, 4, total 4 elements are there, out of which 3 are voltage sources, 1 is resistor. Okay, right. Now you can observe minus 50 minus 10, that means minus 60, minus 60 plus 30, that is minus 30. Minus 30 is equal to, I am bringing this 40i to the right hand side. Since it is negative, it will become positive. Now here 1 0 will get cancelled, right? So I equal to minus 3 by 4 units are ampere. Okay, but here they have given the normal values, right? 3 by 4 you can write as 0.75 minus 0.75 ampere, right? Just observe in option A you are having. Okay, in this way, whenever you are having the closed path in the given circuit, with the help of KVL, you can calculate. Okay, right. But you have to take care about the signs carefully. But generally, most of you are having the awareness with respect to KVL, but most of the students might be doing the silly mistake while they are applying the KVL. Okay, so no issue at all. What you have to do if you want to avoid the silly mistake, when you are considering a closed path, either you can consider clockwise or you can consider anti-clockwise, no problem at all. For every element, you have to consider, you can consider the second polarity with respect to voltage, or for every element you can consider the starting polarity, right? If you follow that convention, you won't do even single silly mistake. Definitely you can get the correct answer. Okay. Yeah. Next question. This is also simple question. Okay. So you can apply KVL because all the elements are contained in closed path, right? You are having one loop, right? So here in this circuit, if you observe, you are having voltage source 100 volt, and you are having here also voltage source 4i, and then you are having two resistors 6 ohm and then 15 ohm. Okay. In this question, we have to calculate the voltage across 15 ohm resistor. Voltage across 15 ohm resistor we have to calculate. Okay. So if you carefully observe, just like in the previous question, in the previous circuit also, two resistors are connected in series, right? See, if you want to do the calculation simpler, based on the possibility, okay, wherever the simplification possible, you can do it. Okay, so in this case 6 ohm, 15 ohm, both are connected in series, we can add, so that means you are getting 21 ohm resistance. 15 plus 6 is 21. Okay, now in this direction current is flowing like this, right? Okay, now you can observe here the polarities are minus, plus, okay, and here polarity is already given plus, minus. And now if you consider this entire resistor as single resistor, here you are getting plus sign, and then here you are getting minus sign, because current is flowing like this, right? Now just apply KVL around this closed path. KVL you can apply. Okay, minus to plus, just like the previous question, I am considering the second polarity. Okay, if you are convenient or if you are accustomed with the starting polarity, accordingly you can proceed, no issue at all. Ultimately the same answer you are going to get. Okay, minus to plus, plus 100, then plus to minus, minus 4i, then once again plus to minus, minus, here resistor value is 21 and the current flowing in it is I, is equal to 0. Okay, right. So here 4i, 21i, both are having negative sign, so we can add. Together you are getting 25i. We can bring to the right hand side, it will become positive. So from here you are going to get 25i is equal to 100. Okay, so here 25 4 times, that means I equal to 4 ampere. I equal to 4 ampere. Okay, but in this question what they have asked? They are asking the voltage across 15 ohm. Okay, voltage across 15 ohm we have to calculate. So voltage is nothing but here resistor into current. Okay, resistor value is 15 into current is I. Just now we got, you can substitute here, right? So 15 into 4, that is nothing but 60. Units are volts. Okay, 60 volts. So that means option D is the correct one. Option D is the correct one. Okay. Next question, all of you give a try. See, in this question, you are having the circuit diagram like this, and in this question we have to calculate the current I. Okay, so here you are having current I that is flowing through 25 ohm resistor like this. Okay, right. So just observe here. See, whenever you are solving any question, especially when you are applying the basic laws, just after reading the question, have some time glance regarding the given circuit. If you are observing the given circuit, then in couple of seconds you will get the thought whether you have to apply KCL or whether you have to apply KVL or from which node we can start or etc. All those things you will be coming to know if you are observing the given circuit. Okay, in this circuit if you observe, in this branch the current I is coming to this particular node, right. In this branch once again the current 5I is entering. So that means in these two branches together current I and 5I together how much current is coming? 6I. So that 6I should leave in this branch. Yes or no? You are applying KCL, that's all. Here I current is coming, here 5I is coming, together 6I should go. Okay. Now the moment you know the current, you know the resistor, you can apply Ohm's law. 6I into 10, that is nothing but 60I. That is the voltage drop across 10 ohm resistor. Now you know the current, you know the resistor. So here also you can apply Ohm's law. By using that you are getting the voltage drop across this resistor as 25I. Now you are having these three elements. Here it is forming a loop or closed path. Now we can apply KVL, that's all. We can apply KVL. So now you can apply KVL around this closed path. Okay, minus 2 plus 170, then plus 2 minus that is minus 25I, then plus 2 minus 60I is equal to 0. Okay. Now once again just like the previous question, these two are having negative sign, that means we can add both, right. So from here what we are getting, 170 equal to 25 plus 60, that is 85 into I. I hope all of you familiar. 85 here how many times? 2 times. See, if you are not that much comfortable, just consider like 80. 2 80s are how much? 160. And then here you are having 5. 2 5s are 10. 160 plus 10, 170. In this way, if you are not familiar regarding the calculation, you just do some approximation. Either suppose if you are comfortable with respect to 90, 2 90s are what? 180. 90 minus 5 is nothing but 85. So that means 10 drop should be there. Yes, 180 minus 10, 170. In this way, you can cross verify, you can solve the question in less time. I equal to 2 ampere, because in the SSC JEE exam, you have to attempt the questions in less time. For calculation, if you are taking more time, definitely the given time is not sufficient. Okay, you may feel regret after the exam over, because there are so many questions which you can solve actually in the given time, but somehow there you couldn't get enough time even for visiting those questions even for single time, right. So if you want to avoid such kind of regrets, make proper planning. Okay, whatever in the given like 2 hours time is there, okay, that 2 hours you make into 2 parts. In the first 1 hour, try to solve the questions, whichever questions after reading the question one by one. Okay, after having one glance you are coming to know, right, whichever after reading the question you will be coming to know whether you can solve or not. If you can solve, immediately do it. If you feel that it may take more time, or if you feel that you cannot solve, you can hold such kind of questions in the first 1 hour, so that in the first 1 hour whatever the questions maximum you can attempt correctly, that too in less time. Try your level best, so that in the next 1 hour whichever questions are taking little more time, you can attempt those questions. And then even if you are leaving some questions which are, you know, the questions like which you are facing too much difficulty, or even if you don't know the concept regarding that questions, even if you are leaving, there is no regret at the end of the exam. Okay, right. So for this question, option A is the correct one. Option A is the correct one. Yeah, next question. So in this question you are having the circuit diagram like this, right. So here the question is, you are having one 11 ohm resistor. So across that resistor, how much voltage you are having? Voltage across the 11 ohm. Okay, right. So here you can solve these kind of questions in multiple ways, okay, whichever method you feel comfort, no issue, okay, but ultimately decide by following which method you are able to solve the question less time. Obvious, that is the best method, okay. Say for example, here for this question, here we have to calculate the voltage drop across this 11 ohm resistor, right? Okay, so now what we have to do? Now what we have to do, just if you observe the circuit, okay, here this part of the circuit can we represent with some equivalent circuit? Are you able to get? Can we replace? Because here you are having current source which is in parallel to resistor. Yes, obviously you can apply source transformation. You can apply source transformation. If you apply source transformation to this circuit, okay, what will happen? Here you are having current source in parallel to resistor, right? Now this entire circuit we can replace with a voltage source in series with resistor. A voltage source in series with resistor. Okay, so here resistor value, whatever the resistor here you are having, same resistor you are going to get. There is no modification. While you are applying voltage source to, like voltage source in series with resistor, that one you can replace, okay, like this configuration, or like this configuration you can replace like this, vice versa, by using source transformation technique, right? But coming to the voltage, okay, current and resistor, just multiply 4 into 1, that is 4 volts. That is 4 volts. Similarly, suppose if you are having like this configuration, if you want to replace like this, now this 1 ohm resistor you are considering as it is. Now the current source value is nothing but voltage divided by resistor, 4 by 1, just like Ohm's law, okay. So you are keeping current source in parallel to resistor, that we can replace as a voltage source in series with resistor. Similarly, vice versa, okay. Now if you have done like this, what is happening? This entire circuit we have replaced like this. Now this part of circuit you can represent here. So here you are having 12 volt source, and then you are having 11 ohm resistor. Okay, now just observe like earlier questions. Earlier, like this question, or suppose if this is not there, it is forming a closed path, okay, or even here you are having closed path like this. Even though it is like initially parallel, but by using KCL we are able to get here one closed path. From there we have done like that. Here with the help of one KVL equation, if you want to solve, wherever with the help of source transformation technique, if you are able to solve the question less time, definitely you can apply, right? So if the moment you have applied like this, okay, what is happening? Here all the elements are contained in series, right? All the elements are contained in series. In series we can add the resistances 11 plus 1, that is nothing but 12 ohm. 12 ohm. Here you are having 12 volt, here you are having 4 volt. Obviously the current is flowing like this, okay. So here I equal to 12 minus 4 divided by 12. So 12 minus 4 is 8 divided by 12. 4 2s are 8, 4 3s are 12, right? So that means you are getting 2 by 3 ampere. 2 by 3 ampere. Okay, now in this question they are asking voltage across 11 ohm resistor, right? So voltage across 11 ohm is equal to resistor value is 11 into current value is 2 by 3. So 11 2s are 22 divided by 3, units are volts. Units are volts. 22 by 3 you are having in option. And here one important point, whenever you are applying source transformation, okay, where you are supposed to find the response, that terminal elements should not get disturbed, okay. Here according to the context, suppose as per the given question, okay, you have to calculate the voltage across these two terminals. Yes, after you have applied source transformation, we haven't modified those two terminals, right? Okay, that is the only precaution that you have to take care, especially when you are applying source transformation, okay, right? Yeah, all of you give it a try. I hope all of you can answer this question, but while you are reading the choices, you may be getting somewhat slight confusion. Okay, all your confusions will be cleared. Okay, if you know one basic rule with respect to series circuit. Okay, so just observe here, you are having one electronic circuit. In that circuit, the potential difference across one particular resistor or the voltage across one resistor, okay, is a fraction of the total voltage applied across the series combination. Such a circuit is called. Okay, now you are having options like this: voltage multiplier circuit, current multiplier circuit, current divider circuit, voltage divider circuit. Which option you are choosing? Yes, option D is the correct one. Option D is the correct one. See, whenever you are having, okay, just for easy understanding, say for example, here you are having, okay, so here you are having 12 volt and here you are having 4 volt, right? Now you can replace or you can do further simplification, right, with respect to voltage source. What you are getting here, 8 volt source this side, okay, and then here you are having 11 ohm resistor, here 1 ohm resistor, right? So whatever the 8 volts is there, okay, whatever the, for this network, you are having 11 ohm, 1 ohm and then 8 volt source, right? So that entire 8 volt source is getting distributed across these two resistors, that's all. That means here we are performing voltage division operation. In series, current will be same, but voltage is getting distributed or getting divided across the elements, okay, right? So that means it is the voltage divider circuit. Okay, now all of you give a try. This is a simple question based on voltage division rule. Here in this question, we have to calculate the voltage drop across 13 ohm resistor. See, you can observe here, just for easy understanding, I have shown in the previous slide, okay, previous question, but you can easily visualize here. You are having one voltage source and then two resistors are there. Whatever supply voltage is there, that is getting distributed across the other elements, right? I hope all of you know the voltage division rule formula. It is very simple. Here in this case, we have to calculate the voltage across 13 ohm resistor. Okay, for this network, whatever the total supply is there, that one you can consider into across whichever resistor you want the voltage, that particular resistance value will come into the numerator. Here in this question, we have to calculate across 13 ohm resistor, so that will come into the numerator. Voltage across that particular resistor divided by sum of the resistances, 13 plus 7. Okay, so here in this case, 40 into 13 divided by 13 plus 7 is 20. So here 20 2 times and 2 into 13, that is 26. Units are volts. Okay, 26 volts, that is option D. Option D is the correct one. Okay, so with this understanding, all of you give a try for this question. Yeah, just observe here, in this question we have to calculate voltage across 5 ohm resistor. This voltage we have to calculate. Okay, and here if you observe this part of the circuit, just observe. Okay, here I am considering like two terminals are there, like A and B. Okay, between A and B, first I am calculating the voltage. Whatever the earlier convention I have mentioned, same. Here you are having plus minus 50, and whatever the voltage source here you are having, that voltage source I am keeping vertical element, then you are getting minus plus, then here you are having 75. Now just tell me whether we have to add the voltages or we have to subtract. Here plus and minus, here minus and plus. Yes, we have to subtract. Whenever polarities are same, we can add. If the polarities are different, we have to subtract. Okay, so here since this value is greater when compared to the other, okay, so accordingly you are getting like this. Okay, 75 minus 50, that is nothing but 25. Okay, right. So you are getting minus plus 25. I hope all of you are getting the clarity. So for this network, to the left of the terminals A and B, you are having minus plus 25. Okay, right? Minus plus 25 you are having. And then if you observe to the right hand side, you are having 12 ohm resistor, you are having 5 ohm resistor, you are having 8 ohm resistor. All the elements are contained in series. Now we can apply voltage division rule, right? So we have to calculate voltage across 5 ohm resistor. In this circuit, the supply voltage polarities are minus plus. That means here you are getting minus 25. In the earlier case, you are having positive, but here you are having negative. Supply voltage you have considered. Now, across whichever resistor you want the voltage, that resistor value will come into the numerator, divided by sum of the resistance. Okay, so 12 plus 8 is 20 plus 5. Okay, I am writing in the direct step, that is 25. So here 25 are getting cancelled, you are getting minus 5. Units are volts, minus 5 volts. Okay, so option A is the correct one. Option A is the correct one. In this way, wherever you are supposed to apply KVL, if you want, you can write the equation, but instead of that, you can write with the polarities. From there, you will be getting the same answer. In fact, you can take care about the sign also carefully. Okay, right. Yeah, this is also a simple question. Here in this question, you are having one supply voltage and then two resistors are there. Okay, and here across this resistor they have given the voltage. Now they are asking that the value of E, So just observe here, you are having 20 volt and then 4 ohm resistor. By using Ohm's law, we can calculate the current. Voltage divided by resistance, that means 20 by 4, that is 5 ampere. Okay, and here all the elements are contained in series. In series, current will be same. Now by using Ohm's law, 5 into 6, that is 30 volts. Right. So now just you can apply KVL or otherwise here I am labeling that this node voltages, suppose node points are AB. Okay, if you want, you can apply KVL, otherwise just know what is the approach I have mentioned, that approach I am following. So here you are having plus minus 20 volt, plus minus 20. Now this 6 ohm resistor I am keeping vertical element, then you are getting polarities like this, plus minus 30. See, I am keeping this resistor vertical element, then voltage polarities you are getting plus minus, plus minus, plus minus. In this case both are same. Now we can add the polarities. 30 plus 20, that is 50. Yes, with respect to AB, left hand side you are having E, right hand side you are having 50. So that means E value is nothing but 50 volts. Okay. Yeah, all of you give it a try. In this question, you have to calculate the power consumed by 30 ohm resistor. So what is your first observation when you look at the circuit diagram? Here all the elements are contained in parallel. In parallel, definitely voltage will be same, right? So here what is the supply voltage there? The same voltage you are having here also, because all the elements are contained in parallel, right? Now in this question we have to calculate power consumed by 30 ohm resistor. So since you know the voltage, okay, V square by R you can write. V square by R. So V value is 300. So for the timing I am writing like 300 into 300. Okay, just to do the calculation simpler. Okay, and divide by R. R value is 30. Okay, so here 30 10 times. Okay, 10 into 300, that is 3000. Units are watt. 3000 watt, that is option B is the correct one. Okay. Next question, all of you give it a try. This is the last question in this session. In this circuit, you are having 45 volt source, you are having one dependent source, but it is the voltage source only, but it depends on the current value. Okay, and you are having 10 ohm resistor. Okay, In this question, they are asking power delivered by dependent voltage source. Power delivered by dependent voltage source. Okay, right. So regarding that particular wording, we'll take it later. Okay, but ultimately we have to calculate the power. Okay, right. So just observe, in this entire circuit, the current I is flowing like this. The current I is flowing like this. And by using Ohm's law, you are getting voltage across 10 ohm resistor is 10 into I. 10 into I. Okay. Now you can observe. See, in the previous case also we have told here, just like in this question, like 30 volt is there, 20 volt is there. We have added, right? So in the similar way, you can observe here 10I and then 5I. We can add because voltage polarities are same, plus minus, right? I hope all of you are getting the clarity. Directly in one step I am writing. Okay, 10I and then 5I. Okay, so if you are adding, then okay, I am writing here 10I plus 5I is equal to the supply voltage, that is 45. So 10 plus 5, that is 15 into I is equal to 45. So here 15 3 times. From here you are getting I equal to 3 ampere. Okay, now the moment you got I value 3 ampere, okay, so that means whatever the current direction as per the given circuit, okay, since you got the positive value, that means the direction of the current is same. Okay, so that means current is flowing here in this particular voltage source like this. Now just observe, current is entering at positive terminal. Whenever current enters positive terminal, just like here in the resistor, current enters at positive terminal. Whenever you are having like that convention, that means actually the particular element is absorbing the power. It is absorbing the power, right? So here if you are calculating the power, okay, whatever the power you are getting, that is absorbed. Okay, with respect to this voltage source, whatever the power, because the current is entering at positive terminal. Okay, see, if you observe this current direction like this, here with respect to this source, current leaves from positive terminal. Whenever current leaves from positive terminal, it is delivering. Okay, so don't underestimate or don't do don't follow any misconception or don't do silly mistakes. Generally, because of the word source is mentioned, that doesn't mean that always. Okay, see, in the given circuit, if you are having only one source, definitely that is going to deliver the power. But in the given circuit, if you are having more than one sources, then some of the sources can deliver the power, some of the sources can absorb the power. Okay, so which sources are delivering the power or which sources are absorbing the power, no need to by heart any formula and all. Just you have to observe whether current is entering at the positive terminal or current leaves from the positive terminal. If the current enters at positive terminal, definitely it is absorbing the power. No matter, even though they might have mentioned the word source. Okay, because sources can deliver the power or sources can absorb the power based on the other network elements that are present in the given circuit. Okay, so that is most important. In this context, this particular source is absorbing the power, right? So power absorbed is equal to, power is nothing but just product of voltage and current, that's all. Here voltage you are having 5I and entering current is I. Power is nothing but the product of voltage and current, but whether that power is positive or whether that power is absorbing or delivering, that you are deciding based on the sign convention. Okay, right. So in this case, I into I is I square. Now you can substitute I value 3 here, then you are getting 5 into 3 square, right? Yeah, 5 into 3 square is 9, so 9 5s are 45. Units are watt. But in this question, what they have asked? Delivered power they have asked, right? Because here delivered power is nothing but, since actually absorbed power is positive, delivered power will be negative. Or otherwise you can write like this, minus absorbed power, that is minus 45 watt. So answer for this question is minus 45 watt. See, in the same question, if they have asked that how much power is absorbed by this dependent source, in that case you have to choose option A. So in this way, according to the context, you have to choose the option appropriately. See, if you observe whatever the questions in this particular session we have discussed, in most of the questions they have given the combination of both the signs, yes or no? In some choices they have given positive sign, in some choices they have given negative sign, right? So you have to take care about the sign. It is most important. Okay, you might be good at calculation wise, but if you are not taking care about the sign, or if you are doing some silly mistake, but if you are in hurry mode, definitely there are the chances you may be choosing wrong answer as the correct one, right? If you want to avoid all such kind of things, you should have the patience. Of course, you should have the speed. At the same time, you should have little bit patience, especially while you are choosing. After you are solving the question, once again read the context. According to the context, whether your answer is correct or not, just have little moment, have some patience. If you feel that is correct, definitely you can attempt. Okay, right. So in this particular session, we have covered the questions based on capacitor, then KCL, KVL, and voltage division rule, right? Similarly, in the upcoming session, I am going to discuss the network theory previous year questions which are asked in the SSC JE in the previous years, right? Regarding the continuation topics like current division rule and then etc. other concepts. Okay, right. I hope all of you got maximum benefit from this particular session, right? So what are the questions we have discussed? I hope all of you got good command over the concept and even method of solving, especially in the less time, in the given time, how to attempt the good number of questions in less time. Okay, and even how to avoid the silly mistakes also. I hope all of you got good command. Okay, right. So I am going to give two important updates. Okay, so as I mentioned at the beginning of this particular session, okay, this is our Telegram channel. Whoever till now not yet joined, so all of you kindly join. As I mentioned earlier, on every day you are getting one quiz question, right, in this Telegram channel. So you are getting all of you are getting one great learning, like on daily basis you are learning one new question, right? So you people can join, whoever not yet joined till now, and it is free for everyone. Okay, and here at our IMS Gate Academy, we are offering live online program. Okay, whoever aspiring to write the GATE exam in the upcoming years, like in the year 2025 or 2026, right? Whoever want to get very good rank in the upcoming years, right? So you people can contact to any of these two numbers. Okay, so our counselors will discuss in detail about our live online program. Okay, here you can see all the features, okay, which are like with respect to our number of classes that we are going to conduct in the live classes, and whatever the books we are going to provide, everything you are having, and what are the tests we are providing. But all these details, if you want to know in detail, you can contact to any of these two numbers. Our counselors will discuss in detail. And in fact, here at our IMS Gate Academy, we are providing each and every resource that is required for all the sincere students whoever want to get very good rank in the upcoming years, right? So you people can contact to any of these two numbers, and please share this valuable information to your friends and juniors whoever targeting to write the GATE exam in the upcoming years, right? So all of you kindly share this valuable information with them. Okay, right. Yeah, and all of you kindly subscribe, whoever not yet done till now. Okay, all of you kindly subscribe our YouTube channel and then click on the bell icon so that you won't miss even single video. Okay, and all of you like and share this video link with all of your friends. So whatever all of you, like whoever attended this particular session, I hope all of you got the confidence regarding network theory subject. Whatever the questions or concepts we have covered in this particular session with respect to SSC JE exam, right? Similarly, whoever like your friends or juniors, right, whoever want to prepare like this, okay, whoever want to practice good number of questions, right, this kind of series of lectures are going to help a lot. So that is the reason all of you kindly like and share, so that they also will attend these lectures and they also will get benefited from these particular sessions, right? So we'll meet you all in the upcoming like one more session, right? So in that session I am going to cover the continuation topics. Okay, right? So thank you everyone.